In this problem, we have to implement a data structure where we should be able to add a word and search a word. So you may recap that we have a similar data structure called trie, where we insert a word and search a word. So it looks very similar to that. There is just slight variation in this. And this problem has been asked quite frequently in Facebook and Amazon. That is, frequency is very high, and less frequently in other companies like Apple, Google, and Uber. So if you are not familiar with trie, I would recommend you watching these two lessons. So there is one lesson on trie examples where I give some concepts and examples. There is no code here. And in this code, again, in this lesson also, I explain trie, but I also give the implementation. This lesson was kind of supplement and was added later to give some more examples of trie. So please make sure you understand how to implement trie, you understand what are tries, and then you should be okay to solve this problem. And in fact, once you have solved this, there is very little change that we need to make in this problem. So we have to implement a word dictionary data structure, and there should be one constructor. So you will do some initialization there. And there are two main methods. Add word, you pass a word. Search word, you pass a word. And just like tries, if we have inserted, let's say, ABCD, and we want to search for ABC, then it should return false. Although this part matches. So when you are storing it in a trie, you will store it like this. So you search for A, you find it. B is one of its child, so you find it. There are other childs. C also you find. So you found all the characters of the word, but still you return false because this is not a end of word while inserting. So while inserting, when we reach the end of word, we set a boolean flag there that this is a end of word. Now let's take an example, then we will write the implementation. So we will construct a word dict, so that I'm not going to write here. There we will just create a children, and we will be working with a small lowercase English alphabets, A to Z only. So only 26 children can be there, and a boolean to denote is end of word. And there is one difference, that is the only difference that makes it different from a normal trie. In trie, we search for a word and we insert a word. Here also we will insert the word, so insert part will remain same. In search, you can pass a word, or you can also pass a dot character. So this is a 27th character, and this can denote any of the 26 characters. So this is the only difference. For example, you insert bad, so we have a root node, then A is there, in second child corresponds to B, we insert B, and or we don't insert, this is just the branch corresponding to B, but it's easier to draw like that, just write B here. So B, then A, then D. Then we have DAD, so D, A, D. Then we have MAD. So in this case, trie is looking very sparse since this is a small example. But if we have many words starting with, let's say, B and A, so it will come here, this common branch will be used, and it will branch from here onwards. So max it can have 26 branches. So we have inserted the words here. Now we are searching for PAD. So there is no child corresponding to P here, only B, D, and M. So it's false. Then BAD. So we come here. We see that there is a branch corresponding to B, then A, then D. So it's found, and we check whether D was end of the word. So while inserting, we have to make this true. So I will draw in rectangle instead of circle for end of word. So this is found. Similarly, AD, dot AD. So here we are not sure. So here is the something like backtracking we will use. So we know that the second and third letters should be A and D, but first letter is not sure. So first letter we need in order to proceed. So what we will do, we will look at all the children which are valid and not null. So here BAD is not null, So we will pass this children this word AD starting from this. So ignore first word, pass a substring of that. Since this dot already matches with this, all the children nodes match with dot. So this first letter has matched. So the remaining task is to search for AD in this branch, search for AD in this branch, search for AD in this branch. So we are calling recursively here. So this if the first letter is dot, then we recursively call search on all its children, passing the remaining substring. So this will look for A, it found A. It will then look for D, it will find D, and it will come here, then check end of word, it matches, so it returns true. And if there is no dot character, there will be no recursion. What we will do, we will start with current from here, current node, and let's say we found B. So we check whether we have a B or not as a children of this. So B is there, so now current comes here. And we come to this word, this letter A. Now we see if there is a or not. A is there, so we move current to this location. So we are moving the current only until either current becomes null or we have searched for all the letters. And if we have searched for all the letters, then we just need to check whether current dot is end of word is true or not. So exact same concept was used in trie, only difference is that here we will look for all the children instead of just picking one path. So let's write a pseudo code here. So inserting is very trivial. So you can initialize current equal to this. Then for all characters C in word, we will check if current's children dot C. So this for A it will be 0th children, for B it will be second children, for Z it will be 25th child. So you convert it to int by subtracting ASCII value. If this is null, then create then current dot children equal to new word dictionary. If it's already present, you don't create it, and then you move current to here, current dot children corresponding to C. And finally, when this loop ends, that is you have reached the end of the word, then you set current dot is end of word true. So this is the insert part and exactly same as trie. Now let's look at search part. So again same thing, we will search for all the words C in word, but we will add one additional condition. If C equal to this dot, then we will look for all the children. For all the children in here, again we have current dot children. So we are looking at all the nodes, and there we will look for if children is not null and children dot search substring. So instead of this, you can keep an index I equal to 0 to word length and then get the character from there, word I. So search in word I plus 1 till end. So this current ith character, we will assume that it matches with all the children. So we will search for I plus 1 till end of this word. We are recursively calling it on each child. So the first time it searches, it will return true. So we will not search for all the occurrences, but just the first word that matches. So this is the only change. But if C is not this character, then again we will do something like this. If current children C is null, return false, else move current to next. So let's write the code. If there is any confusion, it should be clear here. So we will have a children and is end of word as the members. You can use array or vector, whatever you want. Pointers to nodes, and we will call it children. So we have initialized all the children, 26 children with null. Then we will write the add word. So if this node is getting inserted for the first time, then we will create a new node. And finally, when all characters are inserted, we will set to true, and we are done. So insert part is done, this constructor part is done. Finally, we will do the search part. And here we will need, so this is one way of iterating through the characters, other is using index. And here we will use index because later we will need the substring of the word also. So their index will be useful. For int I equal to 0, I less than word dot length. And then let's take a character C. So we will handle this part later. First write the remaining code, which will be exactly same as trie. So if current children C minus A, if this is null, then we return false. If this was not null, this will not execute, so it will come here. And then in the end, if we did not encounter this situation, that is all the characters were found, then we just need to check if is end of word true for not, true for current or not. So return current is not null, and is end of word. So this will work provided there is no dot character. Now we will write the implementation for dot. So here we will need to do for all the children. We will assume that the first character of this word matches with all the children since it's a dot. substr I plus 1. So ith character we assume to be matched. So please make sure to increase this, otherwise it will be stuck forever. So let's say first child is there and we called search on this substring and it returned true. So we return false straight away from here. We will not check for remaining children. But if this child does not return true, we will search for remaining children. Otherwise, return false. If none of the children, that is none of the branches, could find the remaining word, then return false from here. So our answer does not match, it returns false. So let's see why. So it's able to search this third last, that is BAD. It's able to match this also, but for these two having dots, this is returning false. So the error is clearly in this part. So it's returning false. So we are always returning false in this case. So if it's able to search, then we should return true. So this was the mistake. And now it's correct. So let's submit. And the solution is accepted. And we are around 66% of the accepted submissions, that is around 2/3. Now let's write the same thing in Java and Python. Since here the time taken was of higher range, more than 100 milliseconds, there can be instances of time limit exceeding. If the variation, it varies slightly, it doubles or triples. So add part is done. Now let's do the search part. And the Java solution is also accepted. Now we will do it in Python. So in Python, you cannot directly add or subtract two characters. You need to get the ASCII value of those first, and then do the operation. So the add part is done. Finally, let's do the search. And the Python solution is also accepted.